On 5A.
Into the X.
Yes, ma'am.
On the interval.
And find the area between those two.
That's what I did.
Okay.
So on the second one.
Wait, on 3?
G of 3.
Okay, from 1 to 3.
Right.
Isn't it a triangle?
Yes.
Oh, no.
My question was, is it negative still?
Yes, ma'am, because it's under the x-axis.
Hold on.
No. You all cannot all talk at once. All right? Emma's talking, and you're trying to ask me questions in the middle. Now, what's your question?
Wait.
And then the decreasing and increasing, this is a derivative graph too, right?
This is a derivative graph, yes.
It's when the derivative graph is negative. Like
It is decreasing.
On the left side of the graph.
No, on the bottom side, right?
Decreasing is under the x-axis. A negative is under, positive is above.
How would you find the area of G of negative 1?
G of negative 1, isn't that from 1 to negative 1?
Yeah.
So you're going backwards. So first of all, it's negative. Hold on just a second. Right? Because you're going backwards. Now, from 1 to negative 1, isn't that a fourth of a circle? So it's 1/4 pi r squared, and then make it negative because you're going backwards. Right?
Yes. Okay, then I don't understand what we're supposed to do. So we're supposed to plug our number into the x.
Uh-huh.
Right there. Okay, so G of 3, we're going to plug 1. So we look at 1, 2, 3, right?
Uh-huh.
And find the area of that.
Uh-huh.
Okay, so then we do. Okay, all right.
Okay. Who else has a question? Okay, Emma, keep going.
Can we go over like 5C and 5D on how to find minimum
Yes.
maximum?
Okay.
Please.
Are you all listening? Because I'm just going over these once. Okay. The directions say we're looking at the open interval or the interval, -3 to 4. We want to know where it has a minimum and then for D, a maximum. Okay. Doesn't a graph, when it's going from increasing to decreasing, doesn't this give me a max?
Yeah.
Okay, it is increasing when the derivative is positive. And it is decreasing when the derivative is negative. Correct? Now, it has a minimum when I go back the other way, right?
Yeah.
This is a minimum. So on 5C, where does the graph go from, if it's a minimum, it goes from negative to positive. Where on the graph do I go from a negative or below the x-axis to above the x-axis?
3, 0.
1.
No, all I want to know is an x value.
3.
It says find the value of x. You've got to read what it's asking. So it happens when x is 3. Now, justify your answer. Why is that a minimum?
It goes from negative to positive.
It goes from negative to positive.
Okay.
Make sense? So what do you think is going to happen on D?
It'll be 1, won't it?
Positive to negative.
Okay.
At x equal 1?
Yep.
Why?
Because it goes from positive to negative.
Now this one asks for one more. This one says find the absolute maximum value. That is the y. So when you said it happened when x is 1. So when x is 1, what is y?
0.
You found that on part A, didn't you?
Oh, yeah.
So 0?
Yeah. Okay, so does
So
that
do we
mean...
write it as a point?
Well, no, you said, it says find the absolute value, absolute max value. The absolute max is what? 0. And the value of x which it occurs. X equals answer the questions. Okay?
Do we just start by saying from positive to negative?
Uh-huh. Not it. You can never use the word it, because what is it? You can say the graph, you can say the derivative, but you can't say it as a reason. Nobody knows what it is. It can be a lot of things. All right, now what?
For Eve, all of that.
Okay, isn't, you said F.
I think that's the same thing.
No.
No.
Well, okay, I did have a question on E
Okay.
though. So when the,
Isn't it concave up when the second derivative is what? Positive. And the second derivative is positive when the tangent line to the derivative is positive, has a positive slope.
Yeah.
So looking at your graph, where is the tangent line going to have a positive slope? -3 to -1,
Yeah, and then 2 to 4.
and 2 to 4.
okay, so
How do you
since
know
it's a
that?
straight
Wait a
line,
minute. What?
it's a straight line.
Okay. The graph, the first part of the graph looks like this, doesn't it? When I draw a tangent line, what kind of slope does that line have?
Positive.
What kind of slope does that line have? Negative. That's how you know.
But for the part that is just a line, like segments, like how does that, how do you know?
Well, because now it does this, right?
Mhm.
Okay. If I draw a tangent line, what is it doing? It's not going down. It has a negative slope. I don't care which way it's going. It has a negative slope, doesn't it? What does this one have?
Positive.
Positive slope.
So you can do that.
Yes.
I just wasn't sure.
Yes.
Okay.
Okay, now. Where am I? F. Where does it have an inflection point? It has an inflection point when it changes concavity, correct? Now, that means that's where a tangent line slope changes from positive to negative or negative to positive. So what x values does the slope that change from positive to negative or negative to positive? -1 and where else? 2. 2. Right?
Wait, hold on. Why is it? Oh, okay, yeah.
What's the area of a trapezoid?
You're asking me this when I'm thinking about this. 1/2 h times b1 plus b2. So what's my reason?
The
Tangent lines switch from positive to negative.
No, the tangent line slope
Oh.
changes from positive to negative. The line doesn't change.
Okay, so when do you look at this, which is the second derivative? And
That is the first derivative. That graph is the first derivative.
Okay, so then how do we know what the second derivative is? Find the second derivative.
When you look at what the tangent line does, that gives you the second derivative. It's the slopes of the tangent line.
Okay, so
What'd you say was the area?
So can we go to G?
so then why is x equals 1 not an inflection point as well? Because isn't it changing?
What's changing? Isn't the slope of the tangent line still positive for both pieces, or still negative for both pieces? Right here. Is the tangent line negative?
Yeah,
Is the tangent line negative?
yeah. It doesn't really matter, it's just.
No. All right, where are we going now?
I think
I just messed up really bad on the first part of them because, like, I thought you were supposed to use the little thingies, but you're supposed to find the area, right?
Yeah.
Yeah, that's what that means.
so. How do we?
I don't know where we are, Emma.
I'm trying to think of a way to. I'm on G.
Oh, on G, okay.
Trying to think. How do
knowing
Do you know why? When x is -1, do you know why? What is it? So for part G, I know x is -1, y is -pi. What I need to know is what? N. Isn't M, take the derivative and plug x in. So I have the derivative graph, don't I? So when x is -1, what is y? 2. So that means M is 2. Because it's, when you plug x in the derivative, that gives you M. So now I have x, y, and M. That's how I write my equation. Right?
Wait, why would it not just be y?
Guys, you might have to hold that so we can move on, because I still have to teach today's. Today's will be quick, but we still need to get there. What? Because y is -pi. That is the derivative. That is not the original. You get y off the original. All you get off the derivative is a slope.
But if it says write an equation for the line,
Yeah.
you get to the graph.
The graph of G, not y, or not x. So do we have another one, guys?
Yeah, most of 6.
Well, then let's go.
Okay.
What's
Okay.
the area of travel?
1/2 height base 1.
What's your question?
Okay.
So B.
Yeah, B.
It
What
says
is
G prime.
what is the G prime? How does it? What is
Okay. The graph of f is shown, correct?
Yeah. Well, the graph. Is it the graph of G or the graph?
Read what it says.
Well, it says G of x equals.
No, number 6 says the graph of f is shown.
Yeah.
Okay.
You have to read what it tells you. What?
It is a trip.
Yeah.
F is the derivative of G,
So,
right?
Oh.
So my graph is G prime. So what is G prime of 0? 2. Yes.
I have a question on A. So, when you do G of 4, I know I did it, and
That means I'm doing 1 to 4, the area from 1 to 4.
so part of the graph is under.
And it's negative if it's under. Yeah, that was your question, wasn't it?
Yes.
Yes. What's your next question?
Okay. How do you find instantaneous rate of change with respect to x at x equals
The
2?
derivative.
That is derivative. So it is G prime of 2.
Okay.
Remember, if the graph is F, it is also the graph of G prime.
Okay. Absolute max.
Wait, how
We
is
did
that-
absolute maximum. What?
How is it the graph of G prime?
Because it's a graph of F, and it very plainly tells you that F is equal to G prime.
Okay.
If it is a derivative, it is the prime.
Wouldn't that mean that G is equal to F prime?
No. F is the derivative of G. So F is equal to G prime. F is the derivative of G. F equals the derivative of G. Right?
So is that in the let G of x equal?
Yeah. If it's in an integral, it is the derivative of something.
Okay.
So it's derivative of what it's equal to. So F has to equal G prime.
See, that is,
Well,
well, then how do you plug G prime of 0?
what is G prime of 0? Is that a graph of G prime? The graph that's given. Is that the graph of G prime?
Okay, so you just plug it.
So when x is 0, what is y? What about what? E? The second derivative of g is not defined. Are you all listening? The second derivative of g is not defined at x equal 1 and x equal 2. Which of these values are x coordinates are points of inflection? It's a point of inflection when what? It changes concavity. And it changes concavity when the slope of the tangent line changes from positive to negative or negative to positive. So does that happen at either 1 or 2? 1. So the answer to E is, which of these values is an inflection? X equals 1. Why? Not it. The slope, you can say the graph, you can say the integral, you just can't say it.
Okay.
Okay? Okay, you all need to fix this and turn it in tomorrow?
Yes.
All right. Let's do fundamental theorem of calculus.
You have a worksheet today.
Nope. Today we have a book.
We're going to be working on this for the rest of the week, aren't we?
Not this.
Well, the fundamental.
Oh, yeah. Yeah. The rest of the year, probably.
So this is called the fundamental.
Fundamental theorem of calculus. We're on page 294. The fundamental theorem of calculus is on page 294, and it says, first of all, we're going to do part 1. All right? Are you there? And basically, it says, if f is continuous from a to b, then the function has a derivative and is equal to... Yeah. And then if you're interested, it gives you the entire proof. Not thinking you're interested.
Proofs bring me back to Mr. Thor.
All right. So basically, what we're saying today in part 1. Part 2 is a whole different matter, which we will use in a minute, and we will use a lot more than part 1. But part 1 says if y equals, and I know it said a lot of words, but this is basically what it says. 0 to x of sine squared t dt. We're right here. Because we're going from 0 to x, this is equal to sine squared x. That's what it says. That's what part 1 says. I can just simplify it to that. All right? So, if y equals 7 to x of 1 plus t over 1 plus t squared dt, what is this equal to? 1 plus x over 1 plus x squared. What am I doing? I'm replacing the letter with whatever's up there.
You're removing the DP.
Right? I'm taking it out of the integral.
Yeah.
When I take it out of the integral, it goes away. Now, this changes a little bit if I don't have a single x. The number does not affect it at all, whether it's 0 or 7 or 28. The number does not affect it. What affects it is the x. Because, and this one I'm going to throw a lot of things at you here, okay? The first thing, what did I do? It's on the bottom. What happens if it's backwards? What? Uh-huh. Okay. So I know I'm going to go I'm going to make it negative. Agreed?
Why?
Because it's backwards. X is not on the top. Because it's upside down. That matters.
So pretty much X has to be on the top.
X has to be on the top. Yes.
Oh,
Okay.
X. Okay.
Now, what am I putting in place of t this time? X cubed, right?
Yeah.
So I have the cosine for the negative, cosine x cubed, over, isn't this going to be x to the 6th plus 2? Now, because it wasn't a single x, because the derivative of a single x is 1, I didn't have to write it. But now it's not a single x. What is the derivative of x cubed?
3x.
So I have to put the derivative in the problem.
But you
That
leave,
is my answer.
so you leave,
Oh, because X is, okay, that makes so much more sense.
okay, wait, so you leave your x alone in your problem, you write it out like you normally would, but you just take the derivative of that.
And you don't do it for just X because that would be 1.
Yes.
Will we ever need to simplify that after we put the derivative in?
No. No. Make sense? Now, what if I want to write an integral? This theorem also allows me to write an integral. If I am given dy over dx is equal to sine cubed x y is 0 when x is 5. I want to write an integral. My integral is 5 to x of sine cubed t dt.
Okay, how do you know that the x, that the 5 is on the bottom rather than on the top? Do we just assume that, or did?
Because when y is 0, shouldn't we start with the lowest?
Yeah.
That's why.
Does the y value matter?
Huh?
Does the y value affect anything?
No.
Wait,
I'm trying to find one that does it different.
That's
Teachers, students, pardon the interruption. If you still need an operator Christmas child shoebox, we do have those in the front office, and you can come pick them up anytime.
this is a problem, right?
Yes. is 2 to x. Do you agree?
No, okay.
Is
Why are we
there-
not putting 3?
Is there ever gonna be one where it's extra two? Like
No.
how would we
No.
know the difference?
If it was -2, would we,
No. That's how you're going to do it every time.
okay.
All right? Now, it's ln sine of t plus 5 dt, right? Plus 3. Because we started at 3 instead of 0.
Oh, okay,
Does that make sense?
okay.
Good with that? Now, the second part of the fundamental theorem of calculus, which is the bigger deal, and that's, you asked me the other day what this was called when I had, let me get my letters right here. It is on page 299 if you want to look at it. It's also called the integral evaluation theorem, but it says if I have a to b of f of x dx, this is equal to f of b minus f of a.
Are you just the one that they wouldn't alternate?
Yes.
Do we need to know the other name that you said for it?
No.
The integral evaluation.
You just need to know the fundamental theorem of calculus.
That's it.
Now, most of the terms, you learn the derivative so you know to go backwards. But if I have just a normal problem, just a plain old normal problem that I want the it's called antiderivative, is when I'm going this way, because I'm going backwards. And I want to know, for instance, x cubed.
Okay.
What was my original problem?
3.
The shortcut to doing that is I add 1 to my exponent and put the new exponent also on the bottom. So the antiderivative of this would have been x to the 4th over 4. What's the derivative of this?
Oh.
Is it this?
Yeah. That's cool.
So that's because as we get into bigger numbers, that gets more difficult. All right? You ready to do a harder one? Maybe? Then you multiply it. The number.
It's over 4.
The directions say evaluate the integral. Now, I can't really draw a picture of this and find the area, so I'm going to use the fundamental theorem of calculus. Okay? So, isn't this going to be f of 32 minus f of 1? Right? F being the antiderivative. So I need to know what is the antiderivative of this number. What did I tell you to do? Add 1 to the number, 1 to the exponent. Right? What does that give me? Negative 1/5. And put my new exponent in the denominator. So this is x to the negative 1/5 over negative 1/5. Correct? Which I believe is actually negative 5 x the negative 1/5 from 1 to 32.
Yes.
That's what it means when I write this. From 1 to 32. Correct?
Okay.
So now what I'm going to do is plug in the 32, which gives me negative 5 halves minus, now I'm going to plug in 1, which gives me negative 5.
3.5. I shouldn't have had to do that, Mike. How did you get negative 5 halves so quickly?
Really?
Do you guys know?
Okay, yeah.
What's the fifth root of 32? 2.
What?
Where's 32? Oh, X. I wasn't. Okay.
The fifth root of 32 is 2.
Okay, and then why?
Because 2 to the fifth is 32.
And we put it on the bottom.
And I put it on the bottom, made negative 5 halves.
Okay, okay. That makes sense.
He doesn't like it if I do it faster than him. Have you noticed when I do it in my head?
It's just very. It's just.
I'm just trying to keep up.
Yeah, exactly.
All right, let's do another one. Ready? Can I do another one? Okay. This one I'm going to make you think a little bit. What's the antiderivative of cosecant cotangent?
Cosecant. Oh, negative cosecant.
Negative cosecant x
That's what I meant. Negative cosecant.
from pi over 4 to 3 pi over 4? Oh, y'all didn't remember that one, did you?
Why is it that?
Because you
Because-
put it in negative.
Because you're supposed to know the derivatives of all the trig functions.
And that straight line is just the same thing as the curved line, right?
That straight line says, I'm taking the derivative, I'm going to plug in those two numbers. I'm going to find from here to here.
Oh.
Because I don't want to lose my two numbers, do I?
So does the big F in that original
Mean antiderivative.
that means antiderivative? Okay.
The big F, yes. So isn't this negative cosecant 3 pi over 4 minus negative cosecant pi over 4? Right? What's a cosecant?
Oh.
What? Okay, let me ask you this. What's the sine of 3 pi over 4?
3 pi would be.
Okay, you're saying radical 2 over 2. Is that the same thing as 1 over radical 2?
Yeah.
And it is negative or positive? Positive, isn't it?
Yeah.
So if sine is 1 over radical 2, is cosecant radical 2? So I have negative radical 2. Correct? Plus, what's a cosecant of pi over 4? Radical 2?
Yeah, I'm really confused.
What's a sine of pi over 4?
Yeah,
Well, you should.
Where's pi over 4 again? How am I supposed to know?
6 pi over 4. Radical 2 over 2. Okay. And so, okay, cosecant. Why did we take the 2 away?
What?
Inverse, so 2 over radical 2, which would be.
Okay, pi over 4, guys. If this is pi over 4, isn't this 1, 1, and radical 2?
Yes.
What is the cosecant of that angle?
Cosecant, that would be sine opposite over 2.
No, it's not opposite.
Right.
Cosecant is hypotenuse over opposite.
So opposite would be 1, hypotenuse identical to over 1. There you go. I got it now.
We went back basic, but we're here.
Okay.
Okay, I want this. Isn't this actually going to be f of 1 minus f of negative 1? Yes? As of today, I cannot take the antiderivative of r plus 1 quantity squared. So is this the same thing as this? Right?
Yeah.
So what's the antiderivative of r squared?
3r cubed over 2.
R cubed over 3. Right?
Okay.
What's the antiderivative of 2r?
R squared.
R squared over 2.
No.
No? Why not?
R squared.
What?
What's the antiderivative of 1?
R.
From negative 1 to 1.
It's just R squared. Okay.
Why is that R? Because the 2 more is 1. Oh, yeah, but.
Now, what do? Plug in 1. When I plug in 1, do I get 7/3?
Yeah, that's what I got.
Put your mask on. 7/3 minus. What do I get when I plug in negative 1?
Negative 1/3.
Negative 1 over.
Negative 1/3? So what does that equal? 8/3.
Wow.
So if I ask you to find the total area, y equals x cubed minus 3x squared plus 2. Oh, sorry, plus 2x. And I want to find this area. This is the same thing as 0 to 2 of x cubed minus 3x squared plus 2x plus 2x dx.
Okay. 0. And so, okay, the first one's going to be 0 no matter what. So the antiderivative of that would be 0 minus 0.
So is this x to the 4th over 4 minus x cubed plus x squared from 0 to 2?
Yes.
What?
Okay, I'm missing something here. So why aren't you dropping on the x cubed? Why didn't you put it on the bottom? Oh, because the 3 in front and it cancel out.
Yep. We always reduce, because if you don't reduce, the problem gets more complicated.
I forgot that.
So now what am I going to do? Plug 2 in?
Yeah.
Isn't that 4 minus 8 plus 4 minus 0. Is that right? You're going to learn to really like it when that bottom number is 0. You can see why, huh?
Ready. 0. 3, 1, 0.
Yes. Cool.
That's not what they got.
Oh no.
Oh, I know what happened.
What do we do?
Some of it's below the axis and some of it's above the axis.
How are we supposed to know that?
We should have looked at it. So,
Do we graph it or no?
It says the difference is it didn't ask for the value of the integral. It asked for the total area. So I'm going to have to do this in 2 pieces. So guess what? Guess where we're picking up tomorrow? That's right here. All right? We're on page 303. Page 303, and we'll do 2 through 54 even. It will not be due tomorrow.
So do we know how to do all of it, or?
Except most of it, except for splitting this up. Yes. You'd be surprised how much of it you can do.